Hey, what's up YouTube? Today I got something really cool to show you, something that I am putting on one of my new multi-rotors. This is a 20 watt LED and a 20 watt LED driver that I got on eBay from LED HK. I actually got two of them. I got an extra driver and a second LED for 30 bucks shipped. So that's a really great deal compared to what these LEDs normally cost on their own. Now, this is a lot different than the standard LEDs that you guys are used to working with on regular RC vehicles, I'm sure. This is 20 watts. It's a cool white LED. It's massive. Weighs about half an ounce. And you cannot use a resistor with this. Well, you can get away with it, but you'd have to use a massively sized resistor that would waste a lot of energy and consume a lot of heat. So instead of a resistor, we limit the current with this driver. Now this is what's called a constant current driver. And the way this works is it will never allow more than, I think for this LED it's 1.3 amps in at 30 volts. Will not increase the current at all. Now if you just connected this to a 30 volt supply, the current would, like a battery, if you had a 30 volt battery, the current would increase like crazy until you blew the LED. So this is the only thing protecting this guy from exploding. And the other thing that you need to know is if you're going to use one of these on an RC vehicle, these things get hot. These are incredibly bright. I think this one is about 6,000 or 8,000 lumens. There's a lot of heat that it generates when it's running. So make sure that if you're running it on, say, a multi-copter, you have it heat sinked properly to an aluminum part, or you get an aluminum heat sink to shroud around it. I'm going to attach this to my gimbal on my TBS Discovery Pro, but that'll be in another video. And if you guys have the Discovery Pro, I can show you how to hook it up to the gimbal. So like any other LED, it comes with a positive and a negative side. You have your positive and negative input on the driver and your positive and negative output for the LED. So I'll show you how to hook that up. The driver is DC, so we can use between 12 and 24 volts DC to run it. So I'm going to hook it up to this 4-cell LiPo here, which is what I'd use on my copter. So if you guys are flying something, this would be definitely totally usable. And the way this is set up, white is negative and the pink is positive. Little spark there when the cap charges. Now this is very important. You'll see, and I'll bring it closer to the camera so you can see, there's a little indentation on there for negative and positive, and it's very important that you don't confuse those or you risk blowing up the LED. I realize it is a diode and current is not supposed to travel backwards through it, but I am told by some electrical engineer friends of mine that it will still generate a lot of heat as the diode does that blocking. So I'm just not going to mess with it. I'm going to take their word for it and not try to do anything crazy. Alright, so let's check out what this LED looks like when we power it up. Now keep in mind you can technically run these without a heatsink, but only for a few seconds at a time. Alright, ready? 3, 2, 1, here we go. Oh man. That is crazy bright. That's tough to look at. It is pretty much lighting up my whole workshop. You can see my camera aperture is struggling to keep up with it. Now let's see what it looks like looking into my backyard. Alright guys, so here we are out back in my yard. You can see that it is totally pitch black. There is very little light pollution. Now I'm going to power up the LED. You can tell that it is incredibly bright, and I'll try and focus my camera, but you can see that it's very comfortably lighting up stuff 10, 20, 30 feet away. Even stuff that you can't see directly with the camera, I can see comfortably with my eyes. The fence over there, which is about 30 feet away, There's a old swing set back there that's kind of barely lit, but definitely easy to see with the naked eye. See if I can focus in on it a little bit. There it is, just barely kind of ghosted over there. But this LED is immensely powerful. And in the kit you get from LED-HK, you actually get double this output because you're given two of the 20-watt LED chips, totaling 40 watts of output power, or approximately 12 to 16,000 lumens. Okay guys, so here we are back in my workshop. We're about 8 feet from my bench, and I'm going to go ahead and power the LED up and see what you guys can see from there. So the LED here is incredibly bright. It easily lights up my entire bench. Now, I'll pan over to a wall, it's about 16 feet away, and it easily lights up at a probably about 140 degree swath of my basement. The beam width and luminous intensity is amazing on something like this. Pan around back to my workbench, everything is all the way lit, even over to the wall, and I haven't moved the LED really more than about a degree. So it's pretty incredible the amount of light this thing throws in a room that's normally pitch black. Okay, so here we are measuring the output of our constant current driver. Right now with no load we're reading 35.4, fluctuating a little bit upward to 35.5. Now let's attach the LED and see what happens to our voltage. So it's dropping down now because it's constant current. It's dropping to 14.2 volts. And open circuit, it sits at 13.5. Alright guys, so it's important to note that the LED's actual forward voltage is between 15 and 18 volts, which is exactly why the constant current driver drops down. It's got a forward current of approximately 1200 milliamps. Now that can go up or down based on a couple of things, based on your voltage or based on the temperature of the chip itself. Now on their website they specify this LED as between 13 and 1600 lumens, which is shocking to me based on its output power, based on the amount of stuff it illuminates. It is definitely comparable to flashlights I've seen that are advertised, like the xenon ones that are advertised around 8,000 lumens output. So I'll have to actually measure it, but I'm guessing that it's definitely above 1600. Now the driver is pretty well set up too. It will handle a voltage up to 24 volts, so I'm running it comfortably on a 4-cell, which is what many people use on their quads. You could go all the way up to a 5-cell, but I would not chance a fully charged 6 because that should be 22.2 volts. And honestly, you'd be getting so close to the ceiling of this, to the voltage ceiling. I always leave myself just a little bit of headroom to make sure that I don't pop the board. So let me go ahead and hook this up to measure current, and I want to show you exactly how much current this LED is going to suck from your battery when you're trying to keep a vehicle with that running on it in the air. Okay, I just tested the voltage of my 4-cell. It is at 13.7. Which is pretty much completely dead. Right now at idle we've got our constant current driver sucks about 20 milliamps or so. Now let's go ahead and power up the LED. I'll face it away from the camera so you can get a better look at how many amps it's drawing. Now at 13.7, which is a low voltage for this battery, it draws 570 milliamps. Which is pretty low compared to the other stuff on your vehicle, especially if it's FPV, like OSDs, etc. Now the current is going up. That's because our battery voltage is going down. The higher your battery voltage is, because watts or power equal volts times amps, the higher your battery voltage is, the less current it's going to draw. That also is going to happen to draw more current as the LED heats up. So that's what we're seeing. I'm guessing at a fully charged battery that you will see a current of around 250 milliamps, but very difficult to tell based on the temperature of the LED. You will draw more and more current. That's actually why LEDs tend to destroy themselves if they're not properly heat sinked, because as they get warmer, they tend to draw more and more current. So it's very important to have one of those on a good heat sink. The maximum operating temperature for this guy is 60 degrees C, which is, I believe, approximately 140 Fahrenheit. So there you have it, folks. A 20-watt LED. Amazing price. It works out to $15 per unit with LED and driver. If you love to fly FPV, if you want to do some night ops missions, this is amazing. It easily lights your flight path for about 200 to 300 feet. And depending on your camera, if you have a good low light lens on there, you should be able to see even further. So if you like this video, guys, do not ever forget to rate, comment, subscribe so I can keep bringing you more of this awesome tech. And I'm going to figure out how I can mount this on my DJI copter, and all of you guys with, TBS, Discovery Pro gimbals. I will show you how to mount this to the aluminum so it automatically heat sinks and is also panable and tiltable with your gimbal assembly. So until next time, guys, please don't forget to rate, comment, subscribe. Have a good one.